In this video, we will be taking a look at Cubro's approach for NetFlow and IP fix record generation and data enrichment. The solution focuses on the Omnia line of network packet brokers and the NetFlow Optimizer software package. The Omnia line includes the Omnia 10 and Omnia 120, both of which are capable of generating NetFlow version 5 and version 9 flow records, as well as DPI-enriched IP fix records, and this video will be focusing primarily on the IP fix due to the inclusion of application and protocol detection. One or more Omnia units will be deployed across the network and generate flow records on a one-to-one basis, from network traffic fed to the units via taps or span ports. In the case of the Omnia 10, the unit can generate flow data from the traffic traversing its integrated 1 gigabit per second tap interfaces. The Omnia 120 supports speeds ranging from 1 gigabit per second to 100 gigabits per second. The Omnia devices can still perform all of their normal packet broker functions, such as aggregation, filtering, and load balancing, while generating flow records and IP fix records. The biggest drawback to flow data generation today is the sheer volume of sessions any given endpoint creates. Each session results in a flow record, with any device potentially having hundreds of sessions open at any given time. The resulting flow data quickly becomes overwhelming in volume and costly to both process and store. NetFlow Optimizer solves this issue by reducing the volume of flow data while retaining all the information it provides. In contrast, sampling flow data will reduce the volume of records, but at the expense of data fidelity since large amounts of information will naturally be skipped. With NetFlow Optimizer, we can have the best of both worlds. In fact, NetFlow Optimizer further enriches the structured data it ingests with valuable information while also formatting it for a variety of security and monitoring tools. Let's take a closer look at each piece of this solution using the Omnia devices and NetFlow Optimizer, and especially the data output with the enriched fields, and how they are beneficial for monitoring and security applications. With the Omnia devices, we are able to generate basically two kinds of records to output to NetFlow Optimizer. We have the option to output NetFlow or IPFix. The IPFix output will include all the information provided by NetFlow, but leverages Cubro's DPI engine to provide application and protocol detection, regardless of whether the traffic is encrypted or not. When it comes to enabling NetFlow output, this is really quite straightforward. In the web UI of your Omnia 10 or 120, go to the Advanced Function drop-down menu, select the NetFlow tab, and simply click the NetFlow Enable button. This will give us a few more fields for fully configuring the output, the first of which is choosing either version 5 or version 9 NetFlow, then whether we want IPv4 or IPv6. Then we can define the destination MAC address, destination IP address, and destination port for the output of that data. Additionally, we have the option to select a sampling mode and a sampling rate interval. However, as mentioned earlier, this will reduce the fidelity of our output, so we will forego sampling and allow NetFlow Optimizer to do what it does best and handle all the data. Now, while NetFlow is enabled on this device, we have one more step, and that is to enable NetFlow Output and select an interface to forward the UDP stream to NetFlow Optimizer. That's it for NetFlow configuration. Now let's look at IPFix. IPFix is currently configured via the command line interface. If we navigate to the /opt/Cubro folder, we will find a start_VPP shell script where we enter the values for our output similar to the web UI. IPFix runs as a Linux system service, so if we use the command systemctl status IPFix, we can see whether the service is currently running, which it is. If we needed to start the service, we could use the command systemctl start IPFix, and to stop it, we would use systemctl stop IPFix. Now that we have the desired output configured on the Omnia devices, we can move to the NetFlow Optimizer UI. This is already configured to ingest the data from the Omnia we just looked at. Along the top bar here, we can see the input flows per second, as well as the total input flows and the number of output messages. The status screen gives us the same information along with more granular statistics. If we did need to define additional inputs, perhaps we have an IPFix feed coming from a number of distributed Omnia devices, or we are also pulling in NetFlow, SFlow, SNMP, or other structured data from other network elements, we can define that here by simply clicking on the plus icon and defining the UDP port we are sending that data to. We can also define multiple outputs from NetFlow Optimizer. We have the option to send some or all data to a variety of systems. You will see that I already have a few SIMs configured here, and we will be taking a look at our data output in Splunk in a moment. But if we wanted to add more, we again click the plus icon, give the output an optional name. Any of these outputs can be enabled or disabled at any time. And then we get to this type drop-down menu, which is one of the really cool aspects of NetFlow Optimizer, where we're bringing in all of this structured data in various formats: NetFlow, IPFix, SNMP, SFlow. What we are able to do after NetFlow Optimizer processes the data, aggregates it and deduplicates it, and performs data enrichment is standardize the output format to something that is most optimal for the destination tool, system, or database that we are sending to. We have the options of using syslog, very useful for SIMs. We can use JSON, perhaps most appropriate for sending to some analytics or data scraping program. We can simply enable a repeater for the original information, or select ClickHouse, which is built for column-oriented databases. Next, we define our IP address and our port that we are forwarding to. Finally, we can select an output filter, which we will revisit later, but we can forward all of the output from NFO, only output generated by the modules, or only the original NetFlow or IPFix if enabled. This brings us to the modules, which are really the heart of the configuration and data enrichment capabilities of NetFlow Optimizer. We won't cover all of the available options here, but I will touch on a few highlights for configuration and some of the interesting options for data enrichment that we can add to the output. If we jump into Network Conversations Monitor, we see that we have a number of parameters to configure relative to our specific needs, including the number of unique sessions to report and a session timeout. This timeout is used to detect when a session has ended, so the conversation duration can be reported, as we'll see momentarily. This is especially useful in cases where the TCP, FIN, and reset flags are not available, such as sampled flow and UDP traffic. Reporting inactive sessions and enabling bidirectional conversations. This results in the output collected being stitched together to effectively show the back and forth between two hosts. Lastly, data collection interval is important. This determines how often we aggregate together all the data being collected and send it out, in this case every 30 seconds. Next, we get to the watch list parameters, where we begin to see some of the data enrichment properties of NetFlow Optimizer. For example, if we look at list of users by IPv4 address, this allows us to manually define an association between a device and user, or even better, get that information directly from Active Directory, or parse it from syslog, login, and logout events. Here, I've assigned some users to a few IP addresses reported by Cubro's Custos software for the purposes of the demo. When these IPs are detected in the flow records, NetFlow Optimizer will add the user data to the output such that we now have an active user associated to the session in question. We also have the ability to define threat lists, either by uploading custom lists or defining a URL to retrieve a threat list from and parse it with a regex pattern, such as extracting IP addresses from something like the snort reputation list. Now, when NetFlow Optimizer detects one of these IP addresses in the flow data, it will append this reputation score, which will help us detect or alert on suspicious activity or potentially malicious network activity. For example, right from a SIM like Splunk, we will see that the IP address is on a known threat list. In a similar vein, here in the security module, we have the botnet command and control monitor. Much like the threat lists, this represents a list of known command and control channels for botnets, and if NetFlow Optimizer detects an IP in this list, that information will be added to the output record and will be visible right in our SIM that it is a communication to a known command and control server. We can also enhance our output records with geolocation data. All of these things really help to enhance our security posture and reduce time to detection by enriching plain NetFlow data, which would normally just contain source and destination IP address, source and destination port, and protocol, but combined with the DPI application detection from the Omnia devices, this really creates a comprehensive view of what communications are occurring on the network. A few more things to note are the NetFlow Recorder feature. This is effectively like a DVR for incoming data. You can initiate a recording that will be written to disk and can be used for troubleshooting and confirming proper function. And output options, where we can enable things like forwarding original NetFlow, SFlow, or IPFix option templates. This ties back to the output filters we saw earlier. So you could say forward unprocessed NetFlow to certain outputs while sending the processed and enriched messages to others. Now let's take a look at Splunk and get an idea of what our output actually looks like and some of the things we can do with it. Currently, I just have a simple search showing the index containing all of NetFlow Optimizer's output. If we take a closer look at one of these records, this is in syslog format, and this field, NFC_ID, references the module that generated this record. The flow type is IPFix. Where did this information come from? The source is the Cubro Omnia device. We have all of the typical NetFlow information. We see TCP flags, and this value flow count means that this record was produced from one flow record. Here we see the application detection from the Omnia DPI, in this case OpenWeave, and the description tells us OpenWeave is a home area network protocol designed by Nest Labs. The app engine ID is Cubro, again referencing the Cubro DPI engine. We see the flow start time and flow end time, as well as the total duration of the session, and this is an outbound communication. I will add an additional filter to highlight some specific information to take a look at. I'll define the NFC ID to restrict the search to records produced by the Network Conversations Monitor, and also add a filter for flow count greater than 10 so we can see the data reduction properties of NetFlow Optimizer. With those values defined, we can see in this case that this record represents 55 individual flow records. We've reduced the amount of data being sent to Splunk by a factor of 55 in this case. Here's a 14:1 and 16:1. I wonder if we can beat 55. Doesn't look like it, but let's take a look at this record and some of the information it contains. The DPI engine detection tells us that this is TLS traffic, and the username field shows us that this IP address is associated with Charlie. In this case, defined manually, but if Active Directory or syslog were being used, this would reflect the logged in user on this system at this time. Now let's look at this data through some dashboards. NetFlow Optimizer has a Splunk plugin that creates some nice dashboards. Right here we can see that we have detected communications with bad actors. So this is not actually malicious traffic. I created a custom threat list with a known IP to mimic this kind of detection, but we can see the kind of information that is provided from our quote malicious host end quote. Data points like inbound and outbound traffic over time, geolocation data, as well as the conversation summary itself. We can also see the top detected applications by traffic volume, and this is coming right from the DPI enriched IPFix. And here is the breakdown of all the top applications detected on the network. OpenWeave makes another appearance, AWS CloudTrail, Cloud Search, HyperOffice, IMAP. This is all surfaced easily in this dashboard thanks to NetFlow Optimizer. The same applies with users by traffic pattern. We see our 3 users, Alice, Bob, and Charlie, and wherever their associated IP address is detected, it's provided here. And if we single out Alice, we can see all of the communications associated with the user Alice that were detected by NetFlow Optimizer. And here the bidirectional conversations are represented. And with that, I will end this somewhat brief overview of the Cubro NetFlow Optimizer solution. With this, we can achieve a huge reduction in data volume while not only retaining all valuable information, but actually enhancing it as well. Thank you very much for watching, and take care.